Okay, after that, we will go to example 6. This is a more complicated example, okay, and you will see why we would use the method 2 I've mentioned in example 5 more often. Okay, so the example goes like this. We have an 80-liter vessel. Okay, it contains 4 kilograms of refrigerant 134A. Okay, remember here it is R134A, so you need to check no longer table A4 or A5. Okay, we need to check the table, for example, table A11 or table A12, because in the property table we have used so far are only suitable for water only. Okay, for other substances we need other tables. Okay, because of different physical properties of different pure substances. Okay, so this time is R134A, no longer water. Okay, and we have also given the pressure to be 160 kilopascal. And we need to determine the temperature, quality, enthalpy, as well as the volume occupied by the vapor phase. Okay? Again, spend some time to do this problem. Okay? Pause this video now and think of this problem. Okay? Well, I won't wait for you. I have assumed that you have done this problem for 10 days. Okay? So let's go to the solution. Now, we need to first know which table should we go to in order to find the properties. Okay. First of all, we has been given the pressure, but there are a lot of things we don't know. Okay, whether it's saturated or is a compressed liquid or is a superheated vapor. Okay, well, we don't know. But there are some clues that we can find out in this problem to see whether it's saturated, superheated, or compressed. The first clue is of this one, quality. Quality. Quality means the mass of the vapor phase divided by the total mass. This term, quality, you will only see this for saturated mixture only. So this is one of the clues that make us think that it should be in a saturated state. Okay? And in part D, it also asks us to find out the volume occupied by the vapor phase. It means that this quality shouldn't be 0, okay, because we need to find out the volume. So this has given some clue to us on whether it's saturated or not. Okay? But we actually need to justify. We can't just say that, well, because I see this word and then immediately claim that it is a saturated mixture. Okay? Surely not. So we need to do some justification on whether it's a saturated mixture or not. Okay? So because we have given this volume as well as the mass, we can obtain the specific volume of this R134A inside this container. Okay, so let's compute that. The specific volume is equal to the total volume divided by the mass. And the total volume is 80 liter. We need to convert it to our SI unit, which is 0.08 meter cube divided by 4 kilogram, equal to 0.02 m cube per kg. But whether it's saturated or not, we need to check the table. Okay, and because we have given the pressure here, so let's go to the pressure table R134A. It should be table A12. It is a saturated refrigerant 134A pressure table. Okay, let's go to table A12. We need to find out the properties at 160 kilopascal. So here, 160. This is a saturated temperature, and these two numbers, 0.007435 and 0.12355, are the specific volume at a saturated liquid and saturated vapor state, respectively. And you will see that 0.02, the specific volume we have found, lies between these two values. It means that it should be in a saturated mixture state. So we will say that at 160 kilopascal, we know that 0.0007435 is smaller than 0.02. Is smaller than 0.12355. Okay? Okay? Note that this is VF and this is VG. Okay? So this is found from table A12. Okay? These two values. So it means that it is in a saturated mixture state. So we know that it's a saturated mixture, so we can proceed to find out the things that we need to know. Okay, first of all, we need to find out temperature. Well, easy. The temperature is just a saturated temperature at 160 kilopascal. Okay, so let's check the table. 160 here, and this is the saturated temperature, negative 15.6 degrees C. So we just copy this value. Part A done. Okay. How about part B? We need to find out the quality. Okay. What do we mean by the quality? Quality is given by the V average minus Vf divided by Vfg. Okay. This is the formula that we have derived. Okay. Because we have derived V average equal to Vf plus x Vfg, so we can make this x to be the subject. So we will have this term. So how can we find out this x? This V average we have calculated, which is a 0.02. And this Vf we have also found, which is 0.00074335. Okay. What is Vfg? What's Vfg? Vfg is equal to 0.12355 minus 0.0007435. Okay, you'll find that this one is equal to 0.1568, or in 3 significant figures we have this value, 0.157. So about 16% of R1348 is in the vapor phase. Okay, next we need to find out the enthalpy of the refrigerant. Okay, if the question just asks you the enthalpy, it means it is the specific enthalpy. Okay, let me write that down. Okay, in the next example, you will see there's one word called the total enthalpy. The total enthalpy means the total mass multiplied by this specific enthalpy. So this one is what we call H. Okay, while this total enthalpy is the big letter H, or M multiplied by H. Okay. However, if it is me to set up the problems, I would state those names very clearly. For example, it is a specific enthalpy or the total enthalpy. But inside the text box, some of the terms are a bit ambiguous, so I need to clarify here. So here we need to find out the enthalpy of the refrigerant. So how can we find that? Remember, for the problems involving saturated liquid vapor mixture, this X is very important, because this X acts as a bridge to link up all of the properties. Okay? For example, after we have calculated this X, then we can check our table to find out this H average. Okay? And given by our formula, this is equal to HF plus XHFG. Okay? Remember, all of the properties will have this same format. Okay? Just like the specific volume. Okay? All of the properties have the same format. And we can use this X and check the tables to obtain these two values, and then we can get the average specific enthalpy. So this one is equal to, let's check table A12, and then here is 160, and let's see. So this one is the internal energy, and this one is the enthalpy. Okay? So these three numbers are for internal energy, while this one is the enthalpy term. So this one is the HF, 31.18, while this term, 209.96, is the HFG. Okay, HFG. So let us copy these two numbers down. 31.18 plus the quality we have found in part B, it is 0.1568. Okay, multiplied by 209.96. Okay, so you just use the calculator, we get 64.1. Okay, 64.1. Okay, finally, we need to find out the volume occupied by the vapor phase. That is Vg. By definition, is equal to mgVg. Okay, just a definition of a specific volume. But what is this mg? Remember, because we have found out the quality, and the quality is just the mg divided by the m total. So this mg can be obtained by multiplying the m total to the quality. So the total mass is 4 kilogram, and the quality is 0.1568. So this is the mass of the vapor. And Vg is equal to 0.12355. Okay, we have found this in the table A12. And this one is equal to 0.0775 meter cube. Okay, so we have done the whole problem. Okay, remember, in order to find out whether pure substance is saturated, superheated, or compressed, we need some other quantities or properties to help us find whether it's saturated, compressed, or superheated. After we have determined this, we can know what property table should we consult. Okay, so we have found that in this case it's a saturated mixture, so we can go to table A12 and find all of those properties. Okay, so this is example 6. You can see that in this example, this person is very kind. It gives out a lot of steps to guide you. Okay, for example, from A to C, if I just ask you the enthalpy, you may not know what we should do. Okay, but because we have this kind of steps to guide you, so you can quickly determine the enthalpy. But in the next example, which is the general case, the person won't be that nice to ask you first the quality. Okay, so we will see the general style in the next example. Okay.